All right. Hi again with videos from the Ville with Charlie Greenewald. I'm Professor Greenewald, and this is Introduction to City Planning. We're looking at the section called Design with Nature. We're looking at Ian McHarg's classic and landmark study on environmental planning. We went through the first section of Design with Nature last time. We covered seaside development. What we want to do now is move on to how he goes about selecting the most appropriate routes for highway development. Where should highways be located? So this selection of highway route subject is one that he spends a great deal of time on. And remember, in here he looks at the case study of Richmond, New York. Remember, New York City is divided into 5 boroughs. There is the Bronx, there is the Queens, there's Brooklyn, which is Kings, and there's Manhattan, and then you have Staten Island, which is called Richmond. And if you remember, he and his firm were hired to try to determine what it was the best route for a highway to be built across Staten Island. And he uses, we go through the process of using environmental planning to find that route. So, what does he do that's different than what had come before? What does Ian McHarg in environmental planning do to decide what is the best route to build a highway on that hadn't been done before? Well, he uses benefit cost analysis, and he uses a certain type of benefit cost analysis that incorporates many, many different variables. And what he does is he goes on to use overlays or transparency overlays. Every value is put onto a transparency, and when those transparencies are laid upon one another, we can see where there are the most things that humans value and humans shouldn't disturb, and we can see where are the least number of values and the things that humans can disturb, and that will help us pinpoint what's the best route for us to build a highway on. Well, Ian McHarg, in selecting highway routes, wants to use this benefit cost analysis, and he wants to look at all types of variables. We want to look at resources. We do not want to disturb good water supply. We do not want to disturb excellent agricultural soil. We do not want to disturb social values. We wouldn't want to go through a neighborhood that has been there since the Revolutionary War. For example, we wouldn't want to go through the middle of Valley Forge. We wouldn't want to go through the middle of Chinatown in Manhattan, for example. There's social values. And then we have aesthetic values as well. We want to try to keep the landscape as attractive as possible. At any rate, what McHarg ultimately wants is he wants to choose the route with the maximum social benefit and the minimum social cost. That is the key here. He wants to choose the route with the maximum social benefit and the minimum social cost. So his solution is trying to find maximum social utility, trying to find maximum social utility, trying to find maximum social utility. Well, how do we go about finding this route of maximum social utility? Well, I gave it away just a moment ago. We want to prepare transparencies. We want to make transparencies, and we want to map the various social values that occur in the area that we're looking at. what we wouldn't want to disturb, and we want to look at the various physiographic values on the transparencies as well. We don't want to, for example, not only disturb existing water supplies, we wouldn't want to build on prime agricultural land. We don't want to build on land which has steep slopes. We don't want to build on marshland or swampland. These are physiographic values that we need to talk about. And once we put all those transparencies on top of one another, as I said a minute ago, we can see where the darkest areas are and the lightest areas. And when the transparencies are superimposed on this light table, you have a table where light is coming up through the table when you put the transparency down, and you find that when those transparencies are all superimposed on one another, the lightest area is the best route. You find that routes should, if possible, provide new values, a scenic experience for the driver, improved landscaping when possible. And this becomes known not only as environmental planning, but this particular approach becomes known as the ecological method. This is the ecological method. And this is what was used in this case study that's in your book, Design with Nature, to find the Richmond Parkway. The Richmond Parkway was being built by the Tri-State Transportation Commission. This is New York, New Jersey, and Connecticut. The Tri-State Transportation Commission, they decided that they didn't want to transect. They didn't want to go across the green belt of Staten Island, but it selected a special route that Ian McHarg was finally able to discover for them. Well, let's look for a moment at nature in the metropolis and see what our preconceptions are. Our preconceptions about nature in the metropolis is that nature performs different types of work for us without us having to do much, and this work represents a value, such as the bay, for example. Bays filtering water for us and providing an area where fish can reproduce, where birds can nest and reproduce, where all sorts of aquatic life, such as crabs, can reproduce and find refuge. So nature performs types of work for us without our investment. Now, there are certain areas that are inhospitable to man, and certainly natural processes which are inhospitable to man. And we talked about those a little while ago. We don't want to build on floodplains. We don't want to build on earthquake faults. Nature, however, is part of an interacting system, and what happens is generally when you change one part, it affects the operation of the whole. Now, there is an alternative to the ecological method, and the alternative to the ecological method, which has been used for many generations prior, was geometric planning. Geometric planning. Please look at your slide in your PowerPoints under Nature in the Metropolis. Under Nature in the Metropolis. The alternative to the ecological method is geometric planning. The ecological method uses environmental planning that we talked about, as we've been talking about for some time, the method that Ian McHarg uses to try to find the area with the largest and the least amount of aesthetic, social, and physiographic values, and you build where there are the fewest of those. Well, geometric planning is one that, for example, in the past has ringed the city with green belts. But areas where the green belts may be located may not be best suited for agriculture, may not be best suited for recreation, but we simply put something around the area in question. Geometric planning. Our problems when we deal with nature in the metropolis, our problems are the way that urban growth occurs, or the form of urban growth. What happens with urban growth is you have a human settlement pattern, and it becomes denser and denser and denser as it grows. And as it becomes denser, you have the periphery expanding and expanding. As the periphery pushes out from this dense center, open space is what's sacrificed. How much land do we need? The second problem with nature in the metropolis is not only the form of urban growth, but how much land do we need? What's the amount of land that we need for urban growth in the future, now and in the future? Is there going to be a problem in the future with trying to keep those open spaces that perform the natural processes which are so important to us? The filtration of water is one of the most important, for example. Well, we are wondering about the amount of land that's used by human development. In 1961, Jean Gottman showed that only 1.8% of all of America was urbanized. Well, since 1961, you can be assured that at least 5% of America has been urbanized by this time, and every year it increases a little more. Well, as we look for the areas to build and the areas not to build, what are the areas that are least suitable for urban growth? We looked at the seashore and we saw, for example, the primary and secondary dunes and in the bay and the bay shore. The areas that we have throughout nature, throughout our landscape, that are least suitable for urban growth are, one, where there's surface water. We don't want to try to have to be draining large areas to build and eliminating lakes, ponds, and streams and so forth. So an area that's least suitable for urban growth, there are 9 of them. They're listed in your textbook, and I want you to be responsible for them. Number 1 would be surface water. Number 2 would be marshes. After the marshes would come 3 floodplains. Floodplains? Number 4 would be aquifer recharge areas. Aquifers are collections of gravel, sand, loose rock, where water collects, and the water then is filtered into the actual aquifer. They collect water to go into the aquifer, which is much larger than an aquifer per se. There are aquifer recharge areas, and then there are aquifers. Aquifers are where there's lots of water underneath the soil. Then we have, so the areas least suitable for urban growth are surface water, marshes, floodplains, aquifer recharge areas, aquifers. Number 6 would be steep slopes. Steep slopes. Number 7 would be prime agricultural land. Number 8 would be forests. Forests. And number 9 would be very, very flat land. Land that, again, would be very easy to till, to farm. Now, if you go on to your PowerPoint presentation and you look at your slides, you can see this list of areas least suitable for urban growth, 1 through 9, and you go to your next slide and you see nature in a metropolis, and you see a diagram of aquifers and wells and how they function. Well, the presence of aquifers in an area should absolutely close down the usage of any things called injection wells. For example, in Palmyra, in our area, they have never really solved the problem of water runoff. They really have never solved it. And what they did back in the 1930s, I believe, and 40s, is they built injection wells. And their injection wells were places where they took all their water runoff and they simply drilled huge holes into the landscape, and they put the water back into the soil. Well, what's true around the many parts of Lancaster and the Lebanon Valley from Easton all the way to Harrisburg is much of the soil is limestone. Limestone soil, limestone based, which is some of the best farming land that you can find. But what is also true is that water will slowly but surely destroy, break down limestone. So when you have an injection well and you're putting more water into the subsurface areas, you're pushing water down into the limestone, and it results in the limestone breaking down and being eaten away and dissolving. And what do we have? We have sinkholes then. And in fact, sinkholes are one of the major problems for many cities and municipalities in south central Pennsylvania, Palmyra being maybe one of the prime examples. And one of the reasons why they have a problem is that it was self-inflicted through their injection well on the west side of town. The state of Pennsylvania, to the best of my memory, has indeed prohibited, and they banned the drilling of new injection wells. What else is true is we don't want to be building on steep slopes, and essentially the Soil Conservation Service in Washington, D.C. tells us that you should not build on slopes that exceed 12%, 12% incline. So slopes that exceed 12% incline should never be cultivated. These slopes should simply remain as forest land. What else should we talk about when we're looking at nature in the metropolis? We want to look at the presence of air sheds. Air sheds are large areas that are outside of large metropolitan areas where air moves one way or another. A large sort of vacant area just outside of a city, for example, the air moving through there, air can cool, air can heat up, air can come through that will be pure and expel the polluted air that might have been collected in the city. But lots of cities realize that based on the movement of air through their regions that has some type of regularity to it, some pattern, you find that air sheds can be used for atmospheric pollution control. The air sheds can be used for the control of the microclimate. You can try to have a cooler city or a warmer city. Generally, we're looking for cooler. You find that what is the natural process in nature which contributes to pollution? Well, it's inversion, where hot air is not allowed to rise and it's trapped by different layers of air, and then all the pollution and the temperatures are trapped as well. What are the steps that we can use to deal with air pollution? Well, the steps that we can use to deal with air pollution is, number one, clean up the industries. Whatever industry is polluting, we can take a good hard look at it and ways that we should help it stop polluting. You can locate polluting industries downwind of the prevailing winds of a city. Number 5, in regard to air sheds, we can create new air sheds that are 10 to 15 minutes beyond the air pollution sources in upwind areas. The width of an air shed should correspond to the width of the city at the city's core. So steps to deal with air pollution: clean up industries, locate polluting industries downwind of prevailing winds for the city, and to create air sheds 10 to 15 minutes beyond polluting areas and that are wide enough to correspond to the width of the city's core. You find that during the summer, when the temperature rises, the difference between the air shed and the rest of the city could be 10 degrees. It would be 10 degrees cooler. So you look at the temperature of downtown and the temperature of open spaces, and air sheds are simply used to create cooler urban areas. And there is a picture in your slides, in your PowerPoints, of how some air sheds work in the Seattle, Washington area in the Puget Sound. Well, McHargue wants us to look at humans, not only how we go about developing land, but also the values that we take into that process. How do we view our relationship to nature, our relationship to the world we live in? Well, he believes that there have been traditionally in the past there were two views that one could have about development. One is the Judeo-Christian view, and the Judeo-Christian view tends to believe that man must conquer nature, that nature was set here for us, and that we must conquer nature. So that's one way to look at development, that we must conquer nature. Another way was a traditional Muslim view that man is a steward of nature, and that we could make a paradise on earth if we only worked with nature. Now, there are some Muslims that are better examples of that than others. To look at the best example of this view, this Muslim view of man, one would be well advised to go to Spain and go to the city of Granada. And in Granada, at the top of the hill in the middle of town, one can see the Alhambra. The Alhambra is one of the things I wanted most to see in Europe when I went there, and I was able to visit the Alhambra in 1981. We find that the Alhambra is indeed a palace and fortress and a place of worship, but it's also built to be integrated with nature. What you see in the Alhambra is you'll have staircases, and the banister of the staircases is hollowed out, and in that hollow area, water runs down through the stairway to the next level of the building complex. You find there's an abundance of trees and plants and fountains as well. It's truly one of the nicest and most impressive places on the face of the earth that I've ever been. Well, we can move on from highway route selection and how man views nature, how we respond to nature, to looking at another case study. One of the other most important and famous case studies that McHargue has brought to the forefront has to do with the valleys. The valleys is an area That's just east, northeast of the city of Baltimore. As the slide presentation shows, at the beginning of the 1960s, the Valleys was a 45,000 acre rural area just north of the Baltimore Beltway, and it was a prime target for development. All of the area around Baltimore and Washington, specifically around the beltways, was tagged for development. Well, the landowners in this part of the Baltimore area were alarmed. They were alarmed to learn that their area would be developed ultimately, and might be developed with no rationale. It might be developed in just a ad hoc fashion, pell-mell fashion, with no design with no design for the future, and no caring about how nature works and how it impacts man and vice versa. So you see that landowners were alarmed by the possibility of imminent development. So what happened in the valleys was that the landowners formed the Green Spring and Worthington Valley Planning Council. The Green Spring and Worthington Valley Planning Council. And they did this in 1962. They did it with the encouragement of the county government. I found that at this time, that this case study was fairly unique, and it was unique because the landowners took the initiative. It was the landowners that took the initiative. They took the responsibility for deciding that they were going to decide what happened to their neighborhood. They were not going to let some unforeseen forces, they were not going to let some financiers and perhaps some developers come from wherever and determine what their landscape was going to look like and where they would be living when they were done with their dealings. Well, what we find what was true in the early 1960s was that the folks outside of Baltimore believed that they would be subject to uncontrollable growth. Uncontrollable growth, where development simply became denser and denser. And as those developments became more dense, they would throw out tentacles. They would throw out tentacles to create new neighborhoods, or if you will, faceless suburbs, or what McHargue would call No Place USA. McHargue said for many of those people, this process seemed inevitable. But he realized that we need not realize, we may not accept that this was how the area was going to develop and what was going to happen. However, we find that this group of citizens, the group of citizens working with the citizens that formed the council, they developed something called the uncontrollable growth model, and they applied it to their area. And the uncontrollable growth model predicted that there would be in the area a proliferation of development projects, and those development projects would not consider natural processes, and they definitely would not worry about open space preservation. So again, we have the ecological method being brought to this situation by McHargue and his allies and his friends. And there's another name that we can use when we utilize the ecological method, and the other name that we can use is physiographic determinism. Physiographic determinism. Physiographic determinism. Well, the council was able to use physiographic determinism, and what they did was the council formed their own syndicate. They formed their own syndicate of citizens. They raised their own money and donated their own money. And what they decided to do eventually, they decided to buy land development rights. They would buy all the rights to build on this land for all time. So they would buy the land development rights. What would happen in the case of the valleys? There was this recognition that development would become inevitable on the outskirts of Baltimore. There was a recognition that even though that development was inevitable and there was a desire to save the open land of the valleys and preserve that as agricultural land, they also realized that by the year 2000, it probably should be willing and be able to take up to 150,000 new people in the valleys without sacrificing any of the important elements of nature in that area. So the major goal of the people that were working in the valleys was to preserve the rural environment. We want to preserve the rural environment, and we want to save the distinctive valley floors. We want to make sure that those aren't developed. So we're willing to take an extra 150,000 people, but we want to preserve the rural environment as we save the distinctive valley floors. And we're going to accommodate these extra 150,000 people. Well, where was development allowed, and what type of development was allowed? You find that there are different areas, again, in this region, and we find that McHarg sought to define them and to tell us whether or not they lend themselves to development or not. Well, first in the valleys, we have the valley walls without forest cover. Well, valley walls without forest cover should not be developed. There would be tremendous erosion, for example. So you should not allow any development on valley walls without forest cover. And you find that those valley walls must be planted. They must be seeded with all different types of trees, help hold that land in place and stabilize it. So valley walls without forest cover, and then we have valley walls with forest cover. The valley walls with forest cover, the council finally decided that they would permit one house per 3 acres. One house per 3 acres, and that would allow the area to continue to appear wooded. We find that the valley walls with forest cover, we'd allow one house per every 3 acres. We would also find that no development on the slopes that have more than a 25-degree slope would be permitted. So there'd be no development on slopes with more than a 25-degree percentage of slope. Then we have wooded plateaus. The wooded plateaus, the council decided that they would allow one house for every acre, one house per acre. Then they decided on the promontory sites, the high sites. Promontory sites overlooking valleys, for example, they would allow high-rise apartment buildings. They would allow high-rise apartment buildings. You can see these kind of apartment buildings on the west shore of the Susquehanna River across from Harrisburg. You find Harrisburg on the east shore of the Susquehanna River, and on the west side of the Susquehanna River there is a swath of land from Harrisburg on north that elevates much of that riverside. And so the highest parts of that riverside are promontories. And what do we see right across the river from right across the Susquehanna River from the capital of Harrisburg. We see many promontory sites with high-rise apartment buildings, and they're using that land exactly as McHargue would prefer that they do. Well, another part of the landscape would be open plateaus. And we find that open plateaus was where development should be concentrated, according to McHargue. McHargue believed that open plateaus was where the most development should be located. Then we have valleys. Lastly, valleys. Valleys should remain undeveloped. The council specifically organized themselves to preserve the valley floors. So valleys should remain undeveloped as open space. They should remain undeveloped as open space for agriculture, for conservation, and for that aesthetic of open air and open, undeveloped areas, which gives a person a whole different experience in their environment than being in the middle of a city, for example. So valleys should remain undeveloped as open space. And you find that the types of development that we're going to have on the open plateau would be what? Well, the council decided that they would have a variety of different developments on the open plateaus. They decided to have, number one, a country town, a single country town. The single country town was allowed to have 20,000 people. So they would permit on open plateaus, they permit one single country town. Country town would have 20,000 people. They decided they'd have 12 villages, and the villages would each have 5,000 people. And then they decided they would have 12 hamlets. So one single country town of 20,000 people, 12 villages of 5,000 people, and then 12 hamlets. 12 hamlets of 500 people. 12 hamlets of 500 people. So that is the plan. That was the plan that the council came up with for the development of the valleys. You'd have the development on the open plateaus. There would be a single country town accommodating 20,000 people. There would be 12 villages of 5,000 people, and then there'd be 12 hamlets of 500 people. And all of the hamlets, all of the villages, and the single country town thought that it was very important that they would stress a sense of community, and each would have an identifiable nucleus. Each one of them would have a city center, and a city center that everyone knew that it was the city center and agreed. Now, how did they go about making sure that development proceeded this way? Well, they formed a syndicate, and the syndicate, as noted before, they bought development rights. They went all through the valleys and in the surrounding areas, and they bought the rights to develop that land. We find that after the development rights were purchased by the council, the land in that area at that time increased in value by more than $7 million. And what happened was the syndicate shared the increased land value with the valley landowners. They gave them cash payments for not developing their land. We also find that the one thing that's very significant, very useful in controlling development, is if you do not build a highway into the area you wish to preserve. You do not extend sewers into the area that you wish to preserve. So sewer and highway construction was controlled and it was guided. Furthermore, you can follow those very practical things up simply with strong zoning controls. Zoning controls by local government were needed to complete this project in the valleys. The council worked very hard with all the local governments and the state to make sure that sewers and highways weren't extended into the valleys and the valleys were protected. Well, the selection of highway routes, if we go back to that subject for a little bit and we go back to the Richmond project on Staten Island that Ian McHarg's firm worked with, state highway departments really use benefit cost analysis now, as we talked about, and they have a limited number of variables. They have a limited number of variables to decide where the highway route should be placed. What are the costs and what are the benefits? Well, what would be the costs? The costs are always easier to identify in benefit cost analysis than are the benefits. The costs would be the obvious costs of construction. The cost of construction, you have costs for engineering, costs for land and building acquisition, costs for financing, costs for administrative costs as well. Those are some of the construction costs. Then you have maintenance costs as well. Those are some of the things that fall under cost. How about benefits? What are the benefits from one highway project over another? We look for savings in time. If we build this highway, will people be able to save tremendous amounts of time if they use that road as opposed to the old road? Savings in operating costs. If we build this road, will drivers save lots of money because it doesn't cost as much to operate their vehicle going in that that way? And then a reduction in accidents. How many accidents will disappear or diminished? What will those costs be? The value of that be? So we add those things up until we get the benefits. These are the limited number of costs and benefits that are used by most state highway departments. Well, we saw, my machine's not cooperating with me, but we saw that, of course, McHarg, how he changed that. He uses environmental planning, and he uses all the transparencies and the light table, the superimposing of the transparencies on the light table to determine where most of the human values are and where the fewest numbers of them are, and then where the most light is on that light table. That will clearly show you the direction that the highway department should use to build a road, where there will be the fewest values that we're concerned about, whether that is the quality of the soil, the presence of water, the slope of the soil, whether there are social and historic values there, and it makes highway route selection so much easier. I think we've gone through most of McHarg. Some of you may have questions on McHarg. That's natural. Email me, call me, you can text me, you can FaceTime me. I'd be happy to talk to you and communicate with you in any of those forms. And if you have questions on McHarg and on his methodology, I'd be happy to talk with you about that at any time. We're going to close out this, and we're going to move on to the next subject area here. So we're going to close this one out.